Hi there, I'm John from CNCKing.com, and today we make custom floor vents. This custom floor vent was made quite a few steps. The first step for it was, since it's all solid wood, we had to remove a layer of wood underneath. Now the issue with that is that you have a solid piece here. This looks almost like a walnut. And then here you have slats, as you can see, going this way. Now if you just have that, what happens is the vent wants to warp on you. So what you do is you add stainless steel, in this case here, because what we did is we had to remove the slats going the opposite way that held it relatively flat, because it was been too thick for the application the customer had in mind. So what you see here is our CNC router would carve these things out. Our plasma cutter would cut out the stainless steel, and then we bond everything together. The router behind me here actually still has the marks on it from this project here. There were a whole bunch of floor vents that we made different sizes, different specs for this specific customer. And in this case here, what we did is we used a 1/4 inch bit to remove the inside. And then we'd run over it again using a 1/8 bit. What the 1/8 bit does, it makes these corners here, instead of being a 1/4 inch, it makes them a 1/8. So they're a lot, they're definitely more sharp than they would be otherwise. Otherwise, they're sort of a little bit rounded. That requires 2 steps, of course. So you'll see in the video that the router does all the work, then it stops, and then it goes back over all of the holes to make them to the new spec. What that does also is clean up the inside. They still needed to be completely sanded by hand to remove all the little fuzzies, but it removed a lot of fuzzies using a 1/8 bit that was just barely touching the edge and the inner perimeter of each hole. So the part that made this job somewhat challenging is that we had to router out the front here using wood and our CNC router, and then use our plasma cutter to do the vents themselves. Now the vents for the actual production one, this is just a prototype that I'm holding here, a secondary prototype, is that we had a 1/8 margin all the way on the inside and a 1/8 all the way around here. That gave us a little bit of room to maneuver when we're gluing, because whenever you glue stuff onto anything, it tends to want to shift on you very slightly. So giving a 1/8 and a 1/8 inner and outer offset actually made things a lot easier for production wise when it came to glue. Another thing is we use a lot less glue. This one has far too much glue, but again, that's what you learn with making the prototypes versus going to real production. Now for the production version of this, my first thought was let's just cut all the vents out of sheets on the plasma cutter, and that would have worked out perfectly, except I didn't realize how many holes we were making to something like this here. And then by the time the plasma was finished doing all the holes, the sheet would actually move slightly. It doesn't have to move by much, maybe like 1/32, 1/16, which is almost nothing. You can't really perceive it. But you notice it when it's cutting out outlines, and you'll see it in the video coming up, that it cuts this one out perfectly, cuts another one out perfectly, and then the last one you start to see offsets happening because the sheet is warming up. And what happens with metal when it gets hot, it expands. When it cools down, it contracts. But it's even more extreme with the plasma cutter because it's so hot. And you have one section that's really, really hot and one section that's cold because the plasma is nowhere near that. So because of that, you end up warping on all three axes. So how do you solve warping issues with a plasma cutter or any other machine that cuts metal for that matter? The easiest solution is actually to hold it down using weights. And I did that and it worked absolutely perfectly. The other way around that is to get thicker sheets. This job here, as I mentioned earlier, we had to remove a layer of this to add the stainless steel for extra strength for the overall vent. Now, we couldn't go thicker metal because one, it costs a lot more to do, but more importantly, it'd be out of spec for all of these that we already cut out. So that meant one at a time, you put weights all the way around, and the metal still warps a little bit, but because you're doing one at a time and you're doing offsets, so with the router, because we don't have heat to contend with, you know, I could router this one, 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 go this way, not a problem whatsoever. With the plasma cutter, what I did is this one, this one, this one, this one, this one, this one. Because they're more spread out, the heat has a chance to dissipate a little bit more on the project, but more importantly, heat is more spread out, so you end up with extreme warping issues. Now this job specifically I did in 2 batches, and the reason for that is because I literally ran out of clamps in the shop. I've never had that issue before because I have a ton of clamps, and then I discovered while doing this job that a ton of clamps is not enough, I need 1.5 tons. So what I did is I did half the job, did the router, did the plasma cutting, glued it all together overnight, and that bought me time to go to the hardware store and buy about 100 more clamps so that if this ever happens again, now I've got even more clamps to contend with, but I should be able to do the whole job in one shot. I didn't realize how many clamps you need to hold stainless steel flat with a bonding agent onto wood. That was something, you know, when you do a prototype, you just use whatever, it's fine. But when you go into production, that's when you find out really the issues that you have to contend with. I've been designing and doing custom CNC production for almost 20 years. It's crazy how fast time goes. And you always learn something new. In this case here, I learned quite a bit about spacing out my plasma cutting projects, because I never had an issue of this specificity to deal with before. And it's the same thing with the router. You always learn new things about what to do and what not to do. So when it came to do the second batch with the plasma cutter, I had that whole system down, no problem at all. And the same thing with the router, I had that whole system down, no problem at all. So that's part of, when you do a prototype, generally everything sort of works perfectly because you're just doing one. So you run extra slow. You just give yourself a lot of lead time. You're in no rush. I wasn't in a rush for this job either, but I just wanted to get things done. And when you're going in production, one machine working, the other machine working, vice versa, all the way back and forth, that's when you start to find kinks in the armor that you thought you had. So the important part about this job here was that I learned a lot about plasma cutting, specifically with something with so many holes and so little material left over afterwards. And again, same thing with the router. It's just step by step. You learn all the kinks, and then when it comes time to actually doing production, no problems at all. So when it comes to custom floor vents, we can literally make them out of any material, any size, any shape, any spec. We can make them, as you saw, with the stainless steel backing, mild steel. Something we didn't use mild steel is because we were concerned about rusting, but if you really wanted it, we can do that as well. Or titanium, whatever money you have will help you spend it on that end of stuff. Now when it comes to flooring, engineered floorboards, there's endless varieties of them. There's a whole bunch of different finishes, stains, and so forth. So every aspect of this job can be completely customized to your house, however you want it to be presented. So we're looking for custom floor vents, any size, any shape, any material, any spec you have. Contact me at CNCKing.com. We'll cut it out and ship it right to your door.